Okay, so the last time I showed you how to use this LED ring light with just the Arduino Uno, and while it was a very nice example of understanding how multiplexing works, we were using all the available pins on the Arduino Uno. So today I will show you how to use the same LED ring light, but this time using the multiplexing chip being the MAX7219, and that's this chip right here. The main advantage is that we only need 3 pins to drive this chip because this chip uses the SPI connection. And this chip is responsible for updating those LEDs all the time, which means that we only need to send commands from the Arduino to the chip if we want to change the content. Which is quite different from the last time, because in this solution we have to update those LEDs using the Arduino Uno all the time, and there wasn't much performance left for the other tasks. Now this video is sponsored by PCBWay, which you can probably tell by seeing the PCBWay logo on this custom PCB, but more about them later in the video. For now, let's talk about this MAX7219 multiplexing chip. This chip is very popular for Arduino projects, and that's because it's being used to drive those 8x8 LED matrix displays. And I do have 3 videos covering those displays. Here I show some kind of animated counter using the U8G2 library. I've also experimented with SMD stencil overlays to get different shapes for those LEDs. And I've also used this display for a wooden clock project. I will put links to all of those videos down in the description. So the MAX7219 chip usually doesn't look like this. This is a DIP dual inline package. Usually it's the SMD package hidden behind the display. So one chip can control one display which has 8x8 LEDs, so 64 LEDs. And since our LED ring light only has 32 LEDs, we can use one chip to drive 2 LED ring lights. Or as in my case, just drive one LED ring light and just not use all the pins. So the plan for today is to create a custom PCB on which I can place the potentiometer together with the ring light and then snap it instead of the 8x8 LED matrix display. And that should simplify things a lot because you can get this single display module for like $1 and it already has the multiplexing chip and all the other required components. So let's start by connecting this module to the Arduino Uno and lighting up those individual LEDs. And I will start at Vocway, which is a free online Arduino emulator that supports the Arduino Uno, as well as our 8x8 pixel matrix. Now by default it's very large, we only want to have one segment, so I'll go to diagram.json file and change the chains to just 1, and then connect it to the Arduino Uno on the right side. So the clock goes to pin number 13, you can see it's being highlighted, the CS chip select goes to pin number 10, also being highlighted, and data in goes to pin number 11. Finally, the ground of course goes to ground and VCC goes to 5 volts, like so. We need to use some library to drive this display, and previously I was using the U8G2 library, which still could be used, but it's probably an overkill for this kind of simple project. So today I will use the LED control library, which is designed again for the MAX7219. So inside the Vocway I will go to Library Manager, click the plus icon and type in LED control and edit this library. And on the GitHub I will open the examples and go to LC Demo Matrix and open the INO file and copy bits and pieces. So let's just copy the include and the initialization into our sketch, paste it in here. We need to include the library and then we need to set up those individual pins. And you can see that the data in was connected to pin number 12, but in our case the data in is connected to pin number 11. The clock was connected to pin 11, but in our case the clock is connected to pin number 13. And finally what's called the load pin, in our case that's the chip select pin, it's connected to pin number 10, so that's the same pin. So chip select is connected to number 10, and the last parameter says the number of displays. In our case we only have one display. Let's continue with copying the pieces from the example code. Inside the setup function we have this shutdown function which actually wakes up the display. Then we set up the intensity of the display, the brightness, and the clear the display. So I'll copy all of those inside our setup function. And then we want to finally light up some LEDs. We have a few functions to do that. We have the set row function as well as the set column function, but I want to set those individual pixels, and I think that the set LED function is what I'm looking for. So I'll just copy this for loop inside our main sketch, paste it in here, and the only thing that we are using from the original example code that we don't have in our code is this delay time variable. So I'll just copy this delay time variable as well into our project, and I think that we can run the example. And once it's running, it's filling those individual LEDs. However, it seems like that it's filling those from the top right corner, and I would expect that the pixel 00 would be placed on the top left corner instead. Actually, I know that for my display that's the case, so I can stop the simulation and open the documentation for the 8x8 matrix display. And here you can see that we have two different layouts, being the FC16 or Parola, the default being the Parola, but I think that in our case I want to use the FC16 instead, so I'll just copy this value into clipboard, go to the diagram.json file, and in the attributes add one more that will say layout and set it to this value. And if I restart the simulation now, I can see those pixels being filled from the left top corner. So let's try to run the same sketch on the real Arduino. For that, let's copy the code into the clipboard and start the Arduino IDE and paste the code in here. Now, if you have never used the LED control library, let's go to the libraries, type in LED control and install the library. Then select the Arduino board, in my case that's Arduino Uno, and hit the upload button. The connection between the 8x8 LED matrix display and the Arduino Uno should be the same as inside the Vokwi sketch. And once the sketch is running, it should start filling those individual LEDs. Now here is what I want to do. If I light up the first LED, the top left corner LED, I want to light up the first LED on the ring light. And as I light up the second LED, I want to also light up the second LED on the ring light, and so on and so on. So once I light up the first 32 LEDs on the matrix display, at that point all the LEDs on the LED ring light should be shining. So we need to find out what's the connection on this matrix display and then properly connect it to the LED ring light. And if I remove the matrix display, there are 8 pins on the top and 8 pins on the bottom. So I was thinking, well, maybe those are rows and those are columns or vice versa, but that wasn't the case. It turns out that the connection is much more random. Thankfully, I have found this website where the connection is nicely listed inside this table, so each individual column and each individual row and the corresponding pins. And I've used this table to create the image like this, but instead of column, I'm using letter L for LED, and instead of row, I'm using letter C for cathode, and that's because inside our LED ring light, we don't have columns and rows, we just have one strip of light. So here we have, for example, pin number 1, and if I look for pin number 1, that should be cathode number C5, so C5 is matching this, and for pin number 2, it should be cathode 7, so C7, so it's also matching the table. Now you can see that some of those labels have different colors, and that's because we only need 4 cathodes, because 4x8 is 32 and that's the number of LEDs for our LED ring light. So we will not be using cathodes C5, C6, C7 and C8, so those pins will not be connected. We will be only using cathodes C1, 2, 3 and 4. And from the last video, we already know the connection and pins for the LED ring light, which looks something like this. So those are the pin numbers, and those are the corresponding LEDs, going from L1 up to L8 and C1 to C4 for common cathodes. So if you want to light up the first LED, we have to connect pins L1 and C1. So L1 will go to pin number 13, and C1 should be connected to pin number 9. So let's actually try that and see if we can light up the first LED inside our LED ring light this way. Before we do that, I will update the Arduino sketch because now I only want the first LED to be light up all the time, so I'll comment out this piece of code and only copy the lc.setLED function, and I want to set the first row and the first column. Now, by the way, the first parameter of the setLED function is called address, and that sets which matrix display we want to change. And since we only have one matrix display, that will be index of 0. I will set the function to true, so we will light up the first LED, adding a small delay shouldn't hurt, and upload it to Arduino. And now, as expected, only the first LED is shining. I will carefully remove the matrix display from the main PCB because those pins bend very easily. And now it's time to connect the LED ring light based on our image. Now I have this PCB which also lists the pin numbers going from 1 to 8 and then 9 to 16, which I was using as a reference, and I was completely wrong. And that's because for the matrix display, the pin number 1 is actually here and it goes counterclockwise up here. Thankfully, even with this major mistake, the project is still working, and that's because if I rotate the matrix display by 180 degrees, now the pins are matching. So the PCB was supposed to be connected like this, but now it's connected like that. Anyway, let's connect the LED ring light based on our wrong assumption. The L1 should be connected to pin 13 and C1 should be connected to pin number 9. And you can probably tell why I made this mistake, and that's because if I connect it like this, the first LED on the LED ring light is actually shining. So I assumed that the connection is right. However, if I rotated the board by 180 degrees and use the same connection, actually the right connection, now the LED is shining as well. So just to be in sync with the PCB that I've created, for the rest of the video I will be using those quote-unquote wrong pin numbers, or assuming that the main PCB is not positioned like this, but rather like that. And once we have everything sorted out, it's time to jump to KiCad and create a custom PCB. And not just that, for the LED ring light, we would have to probably also create a custom schematic symbol as well as a custom footprint. Let's start the KiCad application and create a new project. We want to start with schematic, so click the schematic editor. And let's start by adding those pin headers, so click the place add symbol. And since we have 8 pins, let's type in the 01 times 08 and let's select this 1x8 connector being the male connector. And what we can do is we can also select the footprint because we know that the spacing of those pins is the default one being the 2.54. So I will go with this connector pin header being the 1 times 8 pins with the spacing of 2.54 millimeters in the vertical orientation and click the OK button. Now before we place it, let's press the R button to rotate it in a way that the first pin is on the top right corner. And then place it like this. We need one more connector, so I can just copy and paste this one and rotate it by 180 degrees and position it like this. Now the pin numbers on the top going from 1 to 8 are matching our PCB, but the pins on the bottom should be going from 9 to 16. But if I change those pin numbers in the schematics, the footprint will not be synced. So what I will do instead is I will keep the pin numbers, but I will also add the pin names. And to do that, I will select the connector, right click and select edit with the symbol editor. Up here it says that editing this symbol will only affect the one that we have selected, which is exactly what we want. And what I want to do is to add a pin name. And if I double click the pin name is already here, but it's not being displayed. So I have to go to edit, symbol properties, and make sure to check the show pin name checkbox, click the OK button, and now we see those pin names. Just move the stuff around a little bit, and we can double click those pins and assign the correct pin names based on our image. Then save the symbol and close this window and do the same thing also for the second connector. So right click and select edit with the symbol editor, move stuff around a little bit, go to file, symbol properties, make sure to show the pin names and then change the pin names according to our image. Then save it and close the editor. There is nothing like the LED ring light symbol built in KiCad, so we have to create that one from scratch. For that I will jump into the KiCad main window and open the symbol editor. In here I will create a new library and let's make this global library and let's call this LED ring light tutorial. It should be automatically selected on the left side and then go to file, new symbol and let's call this LED ring light tutorial as well. We don't want to start from any symbol and I think that we can keep all the settings to default, so just click the OK button and that will add the helper text, which I will move around a little bit. Now a symbol just needs to have a proper amount of connections, proper amount of pins, everything else is extra, but I will still try to draw the symbol in a way that it resembles the LED ring light. Which means that I will draw the circle in the middle and then place the connections around. So click the connection button, add the pin button, click anywhere, and the pin name should be based on our image. This will be L8 and the pin number is 1. The type will be input and everything else could be kept to default. After that I will copy and paste the pin 6 times. Like so, and change the pin numbers as well as the pin names. Then copy and paste the pin on the left side, but before we copy and paste it multiple times, change the orientation to be the right side. Then copy and paste it 6 times, and change the pin numbers and pin names according to our image. What I've also done is I've connected those pins to the circle in the middle using this connection tool, but you will notice that with the default grid settings, sometimes it's not possible to touch the circle nicely. So I will go to View, Grid Properties and temporarily change the grid size to be the smallest possible, and that should help with connecting those lines. Once this is done, change the grid properties to the default settings, which is 1.27 mm, and we can draw one more small circle on the bottom to show the orientation, and if we want we can even set the fill for this big circle. And I think that this is all we need for our custom symbol, so I'll save it, close this window, jump back into the schematic editor, and edit this symbol by selecting Place, Add Symbol, and type it LED ring light, which is this one, so click the OK button and place it in the middle. We probably need to move those connectors around a little bit to have some space. Connecting the LED ring light to pin headers should be simple. We just have to keep in mind that we are not connecting pin numbers to pin numbers, but rather pin names to pin names. So for example, here pin number 1 has the name of L8, so we have to look for another pin that also has the name L8, which is this one, and then L7 should be connected to pin name L7, and so on and so on. Now after you draw it, you can still move those wires around if you feel like a different layout will be better. Keep in mind that we are not connecting all the pins on the pin headers because we are not using common cathodes being the C5, C6, C7 and C8. And so once everything is connected, it can look something like this. Before we create a custom PCB, we need to do few things. First is to annotate the schematics by going to Tools, Annotate Schematics, and by clicking Annotate, that will assign unique IDs to individual components. The second thing is to create a custom footprint for the LED ring light component, and that's because if I go to Tools, Assign Footprints, there is no default footprint that we can use for the LED ring light. So we have to create our own. To do that, I will go into the KiCad main window and select Footprint Editor, then go to File and create a new library, and let's make it global and call it also LED ring light tutorial. Then again go to File and select New Footprint. The name will be LED ring light tutorial as for all the names, and the footprint should be through hole. Click the OK button, and this is our starting point. Same as for the custom symbol, the most important part are the pads, but this time also the position is very important. So I cannot just place those around randomly, I have to set exact positions. And that's a little bit challenging because the positions that I have for the pins are not defined as X and Y positions, but rather as a radius and the angle. And there are many different ways how you can calculate X and Y positions based on those two values. I like to do things visually, so I've decided to use the Adobe Illustrator tool. I have first placed the circle on the Y position being 9.7mm based on this drawing, and then apply the transform effect to rotate it by 25 degrees, and then by 20 degrees by 6 times, and then flip it vertically. So now I have all those 12 pins, and I can select them one by one to get the X and Y positions that I can then use inside a KiCad. So for example, the first pin will be 4.9mm for the X position, so open Properties, and the X should be 4.099, and the Y is 8.791. So paste it in here, click the OK button, and now this is the correct position. It's not super efficient, but it doesn't take too much time for just 12 pins. Once we have all those pads in place, we can draw a circle showing the size of the component, which according to the documentation should be 10.6mm. So I'll just double click this and set it to 10.6mm. And make sure that the layer is set to silk screen. Click the OK button, and it's time to save the footprint by going to File, Save, select the library, there's the LED ring light, click the Save button, and we can jump back to the schematics editor and select again Tools, Assign Footprints. And this time we should have a footprint for our LED ring light, so I will select the library LED ring light and double click this LED ring light tutorial. Click the OK button, and now we can finally work on the PCB by going to Tools, Update PCB from Schematics. There are some messaging being displayed, so just click Update PCB and click the Close button and place those components somewhere. I have measured the size of the matrix display to be 32 by 32mm and decided to make the PCB size the same. So select the rectangle tool and draw any size rectangle, and then right click and select Properties and set the start point to be -16 and -16mm and the end point to be 16 and 16mm. That will make it 32 by 32mm. As for the layer, set this to edge cuts, and that will be the size of our PCB. Positioning the LED ring light should be simple because that one should be on the position 0 and 0, and I've measured the distance between the pins and the edge of the PCB, and that is 4mm. So once I rotate it to the right position, which is this one, the pin 1 should be on top right. The Y position for the top pin header should be -12mm, and the Y position for the bottom pin header should be +12mm. So open Properties, and the Y should be 12. And once we have everything positioned properly, it's time to select the Road Tracks tool and start connecting those pins, like so. For no particular reason, I've decided to make all the connections on the front copper plate, because there's enough space to put those tracks in between the pins if I need to. So this will be the bare minimum version of the PCB. It's not super nice, but it will work. Again, all the tracks are only on the front copper layer and there is nothing on the back. For a final version of the PCB, I've decided to make a few small tweaks. One is to add the potentiometer together with the header pin, because after all the LED ring light is designed for the potentiometer. I've put the pins on the right side and all the connections are actually on the back of the PCB, so those are free connections between the potentiometer and the header pins. I've also placed a lot of text labels, so this text item tool, just to make sure that every pin is correctly identified, so not only the pin numbers, and it's probably better visible in the 3D viewer, but also for every pin there is a pin name, and you can see that for some of those common cathodes, I did put a cross inside to signalize that those are not connected to anything, so C6, 8, C7 and C5 are not connected to anything. I've also put the pin numbers and pin names for the LED ring light, as well as for the potentiometer inside. Now you might have noticed that there is a big hole inside the PCB in the middle, and that's because the potentiometer I have could be mounted in two different ways. I can just place it on the PCB like this, on the front side of the PCB, but I can also put it inside from the back. And in this case I can still keep the connection if I bend those pins, because they should be still touching the PCB. Then I can screw it in place and there is much smaller distance between the PCB and the knob itself. Unfortunately, this will not work today because the potentiometer sticks out too much on the bottom of the PCB, which means that I wouldn't be able to snap it inside the other PCB. But this was more about testing if I can mount the potentiometer this way for my future projects. There is not too much going on the back of the PCB, and since this side will not be visible most of the time, I've decided to test how the individual PCB layers look like. So the white logo is a silkscreen layer, the yellow one is an exposed copper layer. This almost invisible logo is just missing a piece of the copper layer, and then everything is still covered by the mask. And then on the left side there is no mask, no copper layer and no silkscreen, which means that the PCB core layer is being exposed, that's this grayish one. Before exporting the files for manufacturing, it's always a good idea to run DRC, the design rule checker. So if I click the run DRC, you can see I have one error, and that's this hole right here, which seems to be very close to the middle hole. But I think I'm fine with this error because this hole is only used to physically support the potentiometer, meaning for the final project, I will either have those two holes for mounting the potentiometer on the front side of the PCB, or this hole in the middle for mounting the potentiometer on the back side of the PCB, so they will not be used together. So again, in this case it's only for testing. Which means it's time to export the files for manufacturing by going to File, Plot, then click the Generate Drill Files, and click the Generate Drill File, close the dialog, and in here click the Plot button, and that should create all the necessary files for manufacturing. The next step is to go to PCBWay.com, who is also a sponsor of today's video, and not only you can get PCBs, but also PCB assembly, advanced PCBs, CNC machining and 3D printing, as well as assembly stencils, and much more, pretty much anything that you might need for your project. So thank you PCBWay for sponsoring this video, and this time I will be using the PCB prototype, so I'll click Quote Now, and in here I will click Quick Order PCB, and select my Gerber file. You can see that the size is correctly calculated, and we can keep most of the settings to default. A non-functional property but very important is of course setting the solder mask color, and we have quite a lot to choose from. This time I've chosen the blue one. By the way, if you want to create your own PCB and you use the link down in the description of this video, you can get 10 PCBs for free, only paying for shipping. Anyway, let's send this PCB for manufacturing, and while I'm waiting for those PCBs to arrive, I will update the Arduino sketch, actually the Walkway sketch. This is what we have from the last time. We are only setting one LED to be shining, the top left one, while all the other ones are not shining. And I've said it multiple times, let's pretend that this 8x8 LED matrix display is our LED ring display. So this will be the first LED, second, third, this will be LED number 8, LED number 9, 10, 11, 12 and so on, until the last LED, which will be this one, LED 32, because our LED ring light has 32 LEDs. I want to control those using the potentiometer, so I'll stop the simulation and add the potentiometer. So click the potentiometer and then connect it to the Arduino board. The signal should go into one of those analog input pins. I will select A0, so analog input 0. The ground will of course go to ground, and the VCC will go to 5 volts. And if I select the potentiometer, I can click this question mark icon to open the documentation, and there should be a very simple example of setting the pin mode to input, so I'll use the same code in our sketch in the setup function. And then read the value using the analog read function, which I will copy in the main loop, but I will rename the variable to be potentiometer value. Now this will give us values between 0 and 1024. I want to remap it between 0 and 32, so I'll use the map function to remap the potentiometer value which goes between 0 and 1023 to go between 0 and 32. And for setting the LEDs, I will actually reuse this code from up here with some slight modifications. So I will keep the for loop for rows, but only going from 0 to 4 and for columns. And inside here, I will set the LED to true if the current LED index is smaller than the potentiometer value. So I will say if the current LED index, which we can calculate as column plus row times 8, is smaller than the potentiometer value. Only in this case, I will light up the LED. So let's restart the simulation and see what happens. And it looks like I'm missing some bracket, so one bracket for the main loop. So let's restart it one more time. And now as I turned up the potentiometer, I should be lighting up those LEDs. But when I turn it back, nothing happens, and that's because we are only setting those LEDs to true, but we never set them back to false, to not shining. So I'll add the else statement and say that if the LED should not be shining, I'll just turn it off. And now the potentiometer should be working as expected. We can fill or even unfill the LED lights. Now if you want, you can only light up one LED at a time by changing this if statement. Instead of saying smaller than, we can say equals the potentiometer value, and if I restart the simulation now, I will be only moving one dot around. But I like the effect of filling a little bit more, so I will insert the smaller than symbol, and this should be enough for our LED ring light sketch. Thankfully I have the PCBs manufactured and delivered, and they look great. I just need to solder the potentiometer, the LED ring light and the pin headers. I just need to first solder the potentiometer and then the LED ring light, not the other way around because that wouldn't be possible. Also for the pin headers, I cannot use the standard Arduino pins because they are too big for the Max 7219 PCB. I need to use different pins which are slightly smaller, but they have the same spacing, they are actually round as well. And so with everything soldered, it looks like this. In addition to connecting the Max 7219 board, I also need to connect those 3 pins which are for the potentiometer, so again the signal will go to pin A0, and then ground to ground and VCC to 5 volts. Actually I don't have any 5 volt pin left on the Arduino board, so I will use the 3.3 volt pin and slightly adjust the potentiometer reading in the code. Because now the reading will not go from 0 to 1023, but instead only to around 670 or so. And so once everything is connected and the new sketch is uploaded to Arduino, it works. I can turn the potentiometer and I can light up those individual LEDs using the Max 7219 chip. And that's pretty much it. If you have any questions or comments, please put those down in the comment section. Thank you very much for watching and I hope to see you soon. Thanks and bye.